All right, hey everybody. This is reviewing the point ratio form from 5.4 right before we started midterms. So not really dealing with what we have to do in class the past day, but to go back and get you prepared for the quiz that you'll have next two classes, so maybe the beginning of next week. So just to go through, given 2 points, an exponential curve, 2, 6, and 5, 5.2, write an exponential equation and find the starting point. So knowing that this is exponential, we're going to definitely need our point ratio form. And if you recall, it has the formula here, like so. And so we don't know our b, which is our ratio. That's one of the things we have to find out to write our equation. But we do have all these x's and y's because our point 2, 6 is our x and our y, and our point 5 and 5.2 is our x1 and our y1. So I'm just going to plug everything in here. So I have 6 equals y1 is 5.2 times, again, b is what I don't know, what I'm looking for, and then x, whoops, is a 2 minus, and x1 is a 5. So simplifying here a little bit, I divide here by 5.2 and the other side, and that gives me 1.154 equaling b to the negative third. So now I have a power equation, and we know we solve power equations by raising this whole thing to the power of its reciprocal, so to the negative 1/3, and again, golden rule of equations, same thing to the other side. We find out that b is equal to 0.953, and there is our lovely ratio, which we can now use to write the equation. So our equation here, again, we're going to use points ratio form. So we have y equals, I'm going to put in y1, which is that 5.2. And then now I know b. So b is I'm trying to make that a little darker. There we go. 953. And the x minus 5. Now I could have used the other point, and instead of 5.2, I would have used 6. And instead of minus 5, I would have done minus 2. It'll give us the same exact idea. To find a starting point, that would be when x is 0. So that's the second half of the question, find the starting point. So starting point is when x is equal to 0. So I'm going to use that equation that we wrote and just plug in 0 for x. So y equals 5.2 times 0.953, and then 0 minus 5. Simplifying, using our calculator to solve, 5.2 goes 0.953 to the negative fifth power. We get something along the lines, I believe, of 6.1? Something along those lines, 6.61. Let me try. Let me just use the calculator real quick. Yeah, 6.61, sorry. So 6.61. And that would be our starting point with whatever problem this is talking about, real world problem this might be referring to. So we would have our starting point of 6.61. Okay, so a quick review. Let's look at using the same technique with that point ratio form, but in a real world problem. So here's a radioactive material that has a half-life of 20 days. What's the decay rate of the material? And again, this is 5.4 material that we're talking about that'll help you on your quiz, not directly related to what we did in the investigation today. So any radioactive material, half-life of 20 days. They're not giving us much information, so we can kind of make some stuff up here. So if I first get radioactive material, no days have passed. How much material did I get? I don't know. Let's say I got 200 grams of it. I could have picked any number, 50, 10, 5, but I picked 200. And now what happens is in 20 days, it's telling me it has a half-life of 20 days. So in 20 days, I have half the amount of material, so I'll have 100. So if I had started out with 50, then I'd have 25 in 20 days. If I started out with 5, I'd have 2.5 in 20 days, and you get the idea. So that's why we're allowed to make up numbers there, because it's just half of whatever the original point is. And again, I have this point here. Radioactive material has an exponential decay, so we are going to use, again, that point ratio formula to find our ratio. So, doesn't matter. Here's x and y, here's x1 and y1, and we plug away. So 200 equals 100 times, again, b is what I don't know, and then 0 minus 20. So simplifying here, dividing, so I have b to the negative 20 is equal to 2. So now, again, solving a power equation, raising it to the power of the reciprocal, and calculating that, we find out that b is equal to 0.966. So now this is our ratio. The problem is asking for the decay rate. So the decay rate is a little bit different from our ratio. The decay rate is equal to 1 minus the ratio, and then we're going to multiply that by 100 so that we get a percentage. Okay, so this is our decay rate. So what am I going to have? I'm going to have 1 minus 0.966, which gives me 0.034. And then multiplying that by 100 tells me that I have 3.4% is my decay rate of the material. So once you find your ratio, in this case we're not done because it's not asking for an equation, it's asking for a decay rate. So we have to find the ratio first, then we use this idea that the decay rate is 1 minus the ratio, and then we multiply it by 100 to turn it into a percent because the percents are 100 out of 100, sorry. So there's two examples. I'm using point ratio form, which we had done right before midterms. Just wanted to refresh your memory for your quiz that will be coming up in a couple of days. So you can refer back to this at any point in time. Hopefully you took a couple of good notes, and get ready for the screencast on the 5.5 examples.